Okay, today we're going to look at section 3.9, intersection of two lines. So, if we have a graph, we can see where the two lines meet. Okay, that's called the point of intersection. So in this case, x plus y equals 4 is this line, x plus 3y equals 6 is this line, and the point of intersection is 3, 1, because your x axis and your y axis. So 3 on the x, 1 on the y. So 3, 1 is your point of intersection. So if we're asked to find the point of intersection using a diagram, we need to graph our two lines and then put it on the graph and be able to read off our point of intersection. So like we were doing the other day, to draw a line, we let x equal to 0 and find y. So when x is 0, this becomes so y is equal to minus 8.5. So one of my points is 0 minus 8.5, and then let y equal to 0. So 3x minus 2y equals 17. So 3x minus 2 times 0 equals 17. So 3x is equal to 17. Now you're going to end up with decimals and fractions in these, and that's fine. Alright, so 17 divided by 3 is 5 and 2/3. Okay, so you just do it as close to that as you can. And then for the second line, 4x plus 3y equals 0. Also this point is 5 and 2/3, 0. So maybe we'll put that line on the graph first before we do the other line so we don't get confused. So we want to go... No, it might be handy to know how far we need to go on our x's actually, so we won't. So 4x plus 3y equals 0. So let x equal to 0. So 4 times 0 plus 3y equal to 0. So 3y equal to 0, so y is equal to 0. So there's actually, sorry, the point is 0, 0 is on that line. So if this happens where you end up with 0, 0, there's no point letting y equal to 0 because you're just going to get x equal to 0. So just let x equal to 1 and find out what's the value of y when we have one other point. Alright. So 4 times 1 plus 3y equal to 0. 4 plus 3y equal to 0. My pen is running out. So minus 1 1/3. Okay, so 1 minus 1 1/3. Okay, so then we're going to draw our okay, so this is the x-axis, this is the y-axis. So looking, we've 0 minus 8.5. Sorry, I need to move this up here. Okay, so 0 on the y, 0 on the x, minus 8.5 on the y. So that's one of my points. And the other point, so it was 0 minus 8.5 and 5 and 2/3, 0. So 5 and 2/3, 0 is there. So then you have 2 points, you just draw the line. Okay. And then the other point were 0, 0 and 1 minus 1 1/3. So 0, 0 here, 1 minus 1 1/3 is about there. So line them up. And we get our point of intersection of the two lines. So 3 minus 4. Okay, so that's how you do it if you need to do it using a graph. So it says use one diagram, sketch the lines, and use your sketch to find the point of intersection. And here are your two lines. So remember how we do it is we let x equal to 0, find y, let y equal to 0, find x. So there are 2 points for one of the lines. We put them on, we get our line. And then let x equal to 0 in the second line. We ended up getting 0, 0, so then we pick any other number. So 1 is fine for x, and find the y value, because you just need 2 points to be able to draw a line. Okay, so then you might not be asked to use a sketch to do it. Now if you're not told what way to do it, you can use a sketch. But the other way of doing it is to use simultaneous equations, and we need to be able to do that too. Okay, so use simultaneous equations to find the point of intersection of the lines. So we're doing the same thing, we're finding where the lines meet, but we're doing it using algebra methods. So we have our 2 lines. What we need to do is put them together and get rid of either the x or the y. Now this one is straightforward enough because I have a plus y here and I have a minus y here. So if I bring this over and write it underneath, I have a plus y and a minus y, so that would, if I add them together, they'll be gone. Alright, so x plus 2y is 3y, y, take away y, is gone, and 5 plus 4 is 9. So then x is equal to 9 over 3, so x is equal to 3. And once you have x, then you use one of your equations. So this is equation 1, this is equation 2. I'm going back into equation 1 and I'm putting x in for 3. So 3 plus y equals 5. So y equals 5 minus 3, because remember when you bring something over the equal sign, it changes sign. And y equals to 5 minus 3, which is 2. So my point of intersection is 3, 2. Okay. So that one was quite straightforward because y was 1 and y was 1 here, and 1 was a plus and 1 was a minus, so there wasn't much to do. So let's look one of the slightly different. So use simultaneous equations to find the point of intersection of these 2 lines. Okay. Here we have a 3y and a minus y. Now you don't have to get rid of y first, you could get rid of x first, but again we have an x and a 2x. These are opposite signs, so I'm going to still get rid of the y in this one. So what I'm going to do is write this down over here exactly like it is. And for this line, I'm going to multiply everything by 3, because I want the y to be 3 so that the 3y and this 3y will go away. So 2x gets multiplied by 3, so that becomes 6x. Minus y gets multiplied by 3, so that becomes minus 3y. And minus 7 gets multiplied by 3, so that becomes minus 21. Okay, so then x and 6x is 7x. Plus y minus y plus 3y minus 3y is gone. And 7 minus 21 is minus 14. And then to get x on its own, it's minus 14 over 7. So x is equal to minus 2. Alright. Now, again, just for ease, I'm numbered those, and I'm going to bring 1 down here again. Sorry, 3y. And instead of x, I'm going to put in minus 2. And find out what y is. That's a minus 2, so when it comes over, it becomes a plus 2. So 3y equals 9, so y is equal to 9 over 3. So y is equal to 3. So I have my x value and my y value. So the point of intersection is minus 2, 3. Okay? Lovely. So then just one more. So same thing again, use simultaneous equations to solve these, find the point of intersection. So here, this is a 3, this is a 4, this is a 2, this is a 3. So again, we want to turn one of them into the same number but opposite signs. One of these is a minus and one of these is a plus. So let's go with the y again. So how we do it is we multiply the top line. So 3 and 2, what do they have in common? If you multiply them together, you get 6. So if I multiply this by this line by 3, and if I multiply this by line by 2, both of these will be 6's. So I'm going to multiply this by 3, and I'm going to multiply this by 2. So you're multiplying by the opposite number that's there. Excuse me. Now don't forget you have to multiply everything in the line. So 3 by 3 is 9, 3 by 2 is 6, 3 by 17 is 51, and then 2 by 4 is 8, 2 by 3 is 6, and 2 by 0, don't make that mistake, anything times 0 is still 0, okay? So 9x and 8x is 17x, the 6 and the 6 are gone, and 51. So then x is equal to 51 over 17, so x is equal to 3. And then again, just fill it back in. It doesn't matter which equation you fill it into. When x is 3, we want to find out what y is. When the 9 comes over, it becomes a minus 8. So then y is equal to 8 over minus 2. So y is equal to minus 4. So the point of intersection is 3 minus 4. Okay. So you would have met these in algebra also, so hopefully they'll be okay. We'll try some of them for homework. So we're on exercise 3.9, page 70, questions 1 to 8. So 1 or 2 of them is sketch and the rest of them are use simultaneous equations. So give them a go.